Hi everyone, welcome to Numeric Learning. So today is day 15 of Do Math with me, and here we are with a new set of questions. Today we'll be solving some 4 important questions from the chapter Polynomials as a continuation of the daily practice series. So please take your notebook and let's do these 4 very important problems today. The first question of the day is, if alpha and beta are the zeros of the quadratic polynomial such that alpha plus beta is 24 and alpha minus beta is 8, find a quadratic polynomial having alpha and beta as its zeros. You are given that alpha and beta are the zeros of the quadratic polynomial, and you have to also find that quadratic polynomial whose zeros are the two given. But in order to know what is alpha beta, the hint that you are given is you are given the sum and the differences. Okay, so let us go ahead and solve these two equations and get the value of alpha and beta separately. So you are given alpha plus beta is nothing but 24. You are also given alpha minus beta is nothing but 8. Just add them. When you add them, beta and minus beta gets cancelled. Alpha plus alpha is 2 alpha is equal to 24 plus 8 is 32. So alpha is equal to 32 divided by 2, which is nothing but 16. Okay, so alpha is nothing but 16. So you have got 1 0 of the given quadratic polynomial. Now let's substitute this alpha in any one of the equation. So for example, alpha minus beta is equal to 8. We know that. So alpha is 16. So 16 minus beta is equal to 8. Or if beta goes to the other side, beta is equal to 16 minus 8. Right? So here what I have done is beta goes to the other side, 8 comes here. So 16 minus 8 minus beta, when it goes to the other side, it becomes plus beta. Okay. So what is 16 minus 8? It is just 8. So this is the other zero of the quadratic polynomial. Now if you know the zeros, how will you find? If you just know the zeros, you will not be able to find or write a quadratic polynomial. In order to write a quadratic polynomial, you need to know the sum of the zeros. Sum of the zeros. Because the formula for writing the quadratic polynomial is k multiplied by x square minus sx plus p, where s is nothing but your sum of zeros and your p is nothing but the product of the zeros. So if you know the zeros, you can easily write the quadratic polynomial by calculating first its sum. So alpha plus beta. What is alpha? 16 plus beta is 8. So it is 24. Your 24 is nothing but your sum. Now product of the zeros. What is the product of the zeros? Alpha into beta is equal to 16 multiplied by 8. So 8 6 are 48 and 12 128. Now how will you write the quadratic polynomial? K multiplied by x square minus the sum of the zeros into x plus the product of the zeros, right? So k multiplied by x square minus the sum is 24, 24x plus 128. Right, this is your quadratic polynomial. Or default, when k is equal to 1, the polynomial is x square minus 24x plus 128. This is your required polynomial which has got both alpha and beta as their zeros. Okay, so this is your final answer. I hope you understood. So in order to do this question, the very first thing that you have to know is you should know to correctly solve this pair of linear equation. These two are linear equation. You should solve it, right? You're adding them. Why? Because in one of the equation you have a plus beta. The other equation you have a minus beta. So if you just add them, what will happen? Alpha plus beta plus alpha minus beta. Just add the RHS and LHS. 24 plus 8. This also you can do. Beta gets cancelled. So 2 alpha equal to 32. alpha. So it's the same thing, right? If you're just adding both these LHS and RHS together also, it's fine. And then after you find out the alpha and the beta, so these two are the zeros of the polynomial. Okay, these two are the zeros. In order to find a quadratic polynomial, you should know this formula, which is k multiplied by x square minus sx plus p. S is nothing but the sum of the zeros. P is nothing but product of the zeros. You know the zeros, calculate the sum. Just add them and that value is your sum. Find the product of alpha and 0, that will be a product value. And just substitute it in this formula. Right? K into x square minus sum of zeros into x plus product of the zeros, and there you get your answer. Right? This is the required polynomial. It's a very good question, very easy question to do. I hope you understood. Please pause the video and make sure you are doing it on your own and then verify your answer. Let's move on to the next question. Find a quadratic polynomial whose zeros are negative of the zeros of the polynomial px square plus qx plus r. Okay, so the minute you are given a particular polynomial, right? See, you are given find a quadratic polynomial whose zeros are negative of the zeros of the polynomial. So let alpha and beta be the zeros of, let your alpha and beta be the zeros of your given polynomial, that is px square plus qx plus r. Okay. The zeros of the required polynomial will be negative of these zeros, right? So the zeros of the required polynomial will be, what is it given? Find whose zeros are negative of the zeros of the polynomial. So they are negative of alpha and beta. So minus alpha and minus beta. Right? So now for the given polynomial, that is for px square plus qx plus r, what is the sum of the zeros? Calculate the sum of the zeros. Alpha plus beta equal to minus b by a, which is minus q by p. The product of the zero, the formula is c by a, which is nothing but r by p. So we know this formula, which is related to a relationship between, you are relating your zeros with the coefficient, right? Your sum of the zeros is equal to minus b by a. Your product of the zeros will be equal to c by a. This is the relationship between the zeros and the coefficients of any quadratic polynomial. Okay. So once you have got for the given polynomial, this px square, this is the given polynomial, what they have given us, what the question is giving us. For this polynomial, you are assuming alpha and beta are the zeros. And because you have we have already taken alpha and beta as zeros, we have calculated the sum and the product. Now, the required polynomial, the zeros would be minus alpha and minus beta. Now, let us write the required polynomial. Okay. The required polynomial, the formula is k multiplied by x square minus sx plus p. Okay, so for this required polynomial, k multiplied by x square minus, in a square bracket, what is the sum of the zero? Sum of zeros. So for the required polynomial, the zeros are minus alpha and minus beta. So minus alpha plus minus beta, this is the sum of the zeros into x plus the product of the zeros, minus alpha into minus beta, product of the zeros. Okay, so here it is k multiplied by x square minus, take, this is nothing but minus alpha minus beta. Take minus common out, you will have alpha plus beta multiplied by x. Minus into minus is plus, so plus alpha beta. Okay, minus into minus is again k multiplied by x square plus, okay, alpha plus beta into x plus alpha beta. We know the sum and the product, right? Sum is nothing but minus, what is alpha plus beta value? Minus q by p. Alpha beta value is r by p. Let's substitute it here. So you get k multiplied by x square plus minus q by p into x plus r by p. Plus r by p. Okay. So take p as LCM. So what will you get? I'm taking that p outside. Okay. Or I'll probably take it in the next step. So whole divided by p is the LCM. So you have px square minus qx plus r. Am I right? So you can take p outside. So you'll have k by p multiplied by px square minus qx plus r. So this is the required polynomial when the zeros are negative of the given. So the required polynomial, the zeros are negative of the zeros of the given polynomial. Is it clear? So the minute you are given a polynomial, quickly find out the sum and the product using this formula, that is alpha plus beta equal to minus b by a, alpha beta equal to c by a. This is for the given polynomial. Keep these values separate. Now, what is the question asking? You have to find the quadratic polynomial whose zeros are negative of the zeros of the given. So, if the zeros of the given polynomial are alpha and beta, the required polynomial zeros will be negative of alpha and beta, that is minus alpha minus beta. Now, for these two zeros, you have to write the equation, that is required polynomial is k into x square minus sx plus b. Just replace the sum with the zeros minus alpha and beta, the product also, and then finally when you have everything of the form alpha plus beta and alpha beta, then replace the values, that is minus q by p and r by p, and then solve it and you will be getting the required polynomial. Now this required polynomial has the zeros minus alpha and minus beta. Okay, minus alpha and minus beta. This is your final answer. I hope it is clear. Now let's move on to the next question. If the square difference of the zeros of the quadratic polynomial f of x equal to x square plus px plus 45 is equal to 144, find p. Again, a very easy question. So what are you given? You are given your polynomial. So the minute you have your polynomial f of x equal to x square plus px plus 45, get the sum of the zeros alpha plus beta equal to minus b by a. What is b? P. So minus p by 1, which is just minus p. What is alpha beta? C by a. Write the formula always. So 45 by 1, which is nothing but 45. Now, if the squared difference of the 0, what is the difference of the 0? Alpha minus beta. Square difference means square of that. The square difference of the zeros of this particular, the square difference of the zeros of the quadratic polynomial. So here you have alpha and beta are the zeros. The value is equal to, see, the square difference of the zeros of the quadratic polynomial is equal to 144. So this is equal to 144. What is alpha minus a minus b the whole square? A square plus b square, that is alpha square plus beta square minus 2 alpha beta is equal to 144. What is this alpha square plus beta square? Remember the identity. Alpha plus beta the whole square is equal to, that is a plus b the whole square equal to alpha square a square plus b square plus 2ab. Instead of ab, I am writing alpha beta. Therefore, what will be your alpha square plus beta square will be equal to, take this plus 2 alpha beta to the other end. So what will you get? Alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Okay. Now replace it here. Okay. So let this be 1. Let this be 2. So use 2 in equation 1. So what does it become? Alpha plus beta the whole square minus 2 alpha beta. Okay. This is what is the expansion for alpha square plus beta square. Remember, alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Then write this minus 2 alpha beta as it is. Minus 2 alpha beta is equal to 144. What is alpha plus beta the whole square? That is minus p the whole square. So what is, okay, so minus p, alpha plus beta, the value is minus p. So minus p the whole square minus 2 alpha beta minus 2 alpha beta. So minus 4 into what is alpha beta? 45. Okay, so here I have just solved these two and directly written minus 2 alpha beta minus 2. So it is minus 4 alpha beta, right? Instead of alpha beta, I have written 45 is equal to 144. So p square minus this will be 180 is equal to 144. Therefore, your p square equal to 144 plus 180, which will be 324. So p is equal to plus or minus root of 324, which is nothing but plus or minus, it is 18. So you're asked to find the values of p. So the possible values of p are, you have to write at the end. Therefore, the possible values of p are, one is plus 18 and the other one is minus 18. This is your final answer. Okay, so always whenever you have a square root, you should always write it in terms of plus and minus. Please do this problem and see. Okay, but in order to do this problem, this formula is very important. You have to learn this problem, that this identity, that is alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Okay, this is very important. Only then can you replace this alpha square plus beta square with this formula. That is, the identity is alpha plus beta the whole square minus 2 alpha beta. So this identity is extremely important. Only then will you be able to replace everything that is needed in terms of alpha plus beta and alpha beta, because these are the only two values that you know. So we have written everything in terms of, we have converted everything in terms of sum of the zeros, product of the zeros, so that you can substitute the value and find out the unknown term, that is your p. Let's do the last question of the day. Okay. If alpha and beta are the zeros of the quadratic polynomial f of x, so the minute you get your polynomial, immediately find out the sum of the zero and the product of the zero. You have to prove some expression, LHS equal to RHS. First of all, let us write the given polynomial, that is x square minus px plus q is the given polynomial. Immediately first write the sum of the zeros. Alpha plus beta is equal to minus b by a. That is equal to minus of b is nothing but minus p by 1, which is nothing but just p. The product of the zeros alpha beta is equal to c by a. C is q, a is 1, which is just q. Okay. Let us take the LHS part, the left hand side part. When you solve, you will be getting the RHS. Let us take the LHS, nothing else. From the given polynomial, you have found out the sum of the zeros using the formula alpha plus beta equal to your minus b by a. See the previous DPPs. Okay, so this series is a part of Do Math with Me, and we have been doing a lot of problems every day for 20 minutes, approximately 20 to 25 minutes, or even less than that, for the past 13 to 14 days. So please make sure you are seeing that recording. Take your time. Go through at least 2 old DPPs if you haven't. If you are new to this video, please make sure you complete it, and then you will be seeing a continuity, because if you had seen yesterday's and day before yesterday's, this will be easier for you. That is, whenever you're given a polynomial, a quadratic polynomial, you have to know this particular relationship between the zeros and the coefficients. Alpha plus beta equal to minus b by a. Product of the coefficients is equal to c by a. Now let us write the LHS part of what we have to prove. That is, your alpha square by beta square plus beta square by alpha square. Okay. So when you take the LCM, what will you have? Alpha square, beta square is the LCM. So in the numerator, you will have, see, beta square multiplied by what will give you alpha square, beta square? It will be alpha square. This alpha square multiplied with the numerator. So you will be getting alpha to the power 4 plus, same way, alpha square multiplied by what will give you alpha square, beta square? It will be beta square. This term you have to multiply it with the numerator. So it is beta to the power 4. Right? Now let us write a relationship, something that we just learned. We just now learned in the previous question that alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. I can write alpha to the power 4 as alpha square. Let me rewrite it. Alpha to the power 4 plus beta to the power 4. I can write it as alpha square the whole square plus beta square the whole square. Okay. Now, in place of alpha, I have got alpha square. In place of beta, I have got beta square. So, replace alpha with alpha square, beta with beta square in this particular identity. So, it will be alpha square plus beta square the whole square minus 2 alpha square beta square. Is it correct? Now, this is the formula for alpha to the power 4, beta to the power 4. So, let's replace this here in this above one. Okay, so you will be getting, the numerator will be, instead of alpha to the power 4 plus beta to the power 4, I am going to write alpha square plus beta square the whole square minus 2 alpha beta the whole square divided by the denominator will also become alpha square beta square. I can write it as alpha beta the whole square. Now this again, this term we don't know that, this term, right? Alpha square beta square we don't know. All we know is alpha plus beta, sum of zeros and product of the zeros we know. So let us apply this identity here. See, alpha square plus beta square is the one which is within the square. So replace it with the identity which is alpha plus beta the whole square minus 2 alpha beta, again the whole square, minus everything else remains the same. 2 alpha beta, 2 into alpha beta the whole square divided by alpha beta the whole square. Now see, everything we have, every term in the numerator is converted in either in terms of sum, product, product, product. Now let us replace the value. What is alpha beta? What is alpha plus beta? It's p. So p square minus 2. What is alpha beta value? Look here. What is alpha beta? See, sum is p, product is q. Okay. So the product is q. The whole square minus 2q square divided by q square. Okay. Now open the bracket. What is it? This is of the form a minus b the whole square. What is a minus b the whole square? A minus b the whole square is equal to a square plus b square minus 2ab is the identity. So let's replace it. Okay, let's use that identity here. So p square the whole square, a square. A itself is p square. So a square will be p square the whole square, which is p to the power 4 plus 2q the whole square, 4q square minus 2 into p square into 2q. Be very careful with the sign. Okay, minus 2q square whole divided by q square. Okay, write it every step. Please write it carefully. So you have p to the power 4 plus 4q square minus 4p square q minus 2q square divided by q. So I'm just following it. Okay, now this is a like term, right? These two are like terms. So just combine them. So what will you get? P to the power 4 plus, what is 4q square minus 2q square? It's 2q square minus 4p square q divided by the denominator is q square. Now just split it up. Okay, split the q square among the three terms. So you have p to the power 4 divided by q square plus 2q square divided by q square minus 4p square q divided by q square. Okay, so q square will get cancelled. Here 1q will get cancelled. So what do you get? P to the power 4 divided by q square plus 2 minus 4 p square by q. This should be your RHS. Probably you'll have to rearrange it and write. So we can still rearrange it and write p to the power 4 divided by q square minus 4p square divided by q plus 2 should be equal to your RHS, which is asked in the question. See, p to the power 4 by q square minus 4p square by q plus 2. Yeah, so this is your RHS. Definitely these are the kinds of questions which you have to be very, very good at. Okay, so this is equal to your RHS, hence proved. You have to prove it. So these are the kinds of questions with even in tomorrow's DPP I will be doing it. So please make sure you do these questions positively. So this is the kind of practice that you need in your 10th. So this Do Math with Me is exclusively for students like you who are currently in 10th preparing with a goal to get 95% or 100% marks in your mathematics exam. So it's a year-long hard work. Definitely practice. I'm sure if you practice, pause the video, listen to the video once, see every step of the way, and then try it yourself. I'm sure it will be useful. So, and every Sunday, that is tomorrow also, if you're seeing the recording, today happens to be Saturday, and tomorrow 6 p.m. I'll be coming on YouTube live for 1 hour, 6 to 7 p.m. IST, and we will be having some important MCQ questions for 1 hour, as much as we can during that 1 hour from the chapter Polynomials. So please do not forget, keep a reminder and definitely do join. You can ask any doubts at that time. Hoping to see you, and let's keep learning. Be motivated, be very confident. Hard work never fails. So just keep solving problems every day and you will definitely get better at it each day. So happy learning. Thank you. See you all in the next video. Do share, do subscribe.